All right, we're going to go over the activity we did in class where we rotated through and tried some different solubility curve reading and calculations. So I know depending on which group you're in, you did, whichever different set of questions. I'll go over all of them. But again, the first set of questions were the same regardless of which group you're in. So it's just a matter of, which solu where you're asked and what conditions were you given. So notice how I have this graph marked up. That would be the thing to do. Either using a ruler or a straight edge just to make sure that you're looking at the correct places. The other thing to be careful about is, on this graph in particular, they do have these little dots which kind of give you the scale. So between 60 and 80, there's 10 of these dots, or there's 10 sections between the dots. So that would mean then that each one is 2 grams down here on this axis. Each one dot would be 1 degree Celsius. Okay, so in 100 grams of water at 50 degrees Celsius, we're looking at lead nitrate, so make sure you're looking at the right line. 50 degrees Celsius, read up, read over, there's the mark. And so that is almost halfway between, but again, if you count up how many marks, that's about 88 grams per 100 grams. The shorthand notation, there it is right there. So the temperature is a superscript, and then the solubility per 100 grams of solvent, you just write the grams of solute there. So if the solubility limit for number 3, we're asked about 40 grams in 100 grams of water. Notice I bothered to write this down so that I could see what I'm comparing it to. So if we're looking at 30 degrees Celsius, then that means that we're at about 68 grams that are capable of dissolving. And so adding 40 grams is definitely less than that. So we basically, to answer this next question, subtract the difference. So if I had 68 as my solubility limit, then if I only put in 40 grams, that means I have 28 more grams that I could possibly dissolve. And then lastly, this is just scaling up using a ratio or a proportion. All right, so it's 88 grams per 100 grams of solvent. So if I scale that up 4 times the amount of solvent, I could dissolve 352 grams. Now, if you read these numbers slightly differently, if you're very, very close, like within 1 or 2 grams or within 1 or 2 degrees when we get to a question like that, that's, obviously affect the future answers, but, that's how you would figure them out. So if I look to set 2, notice there's the answers for all of those if you worked on set 2. So looking at ammonium chloride, right, so ammonium chloride, there's the highlighted line. So notice the various answers you can posit if you need to. And then lastly for set 3, there is potassium chloride. So there's all the numbers for that. All right, so moving on to the set B questions, which you did next. So for set B, what temperature would you need to heat 200 grams of water? So notice what I did first. So write out your thought process as you go. So this is 200 grams of solvent, right, and 100 grams of lead 2 nitrate. So I put that down. So what I'm looking for on the graph, since the graph is in terms of 100 grams of solvent, then I need to, this would be a proportion. So I solved for that this would be 50, right? So that's half the amount of solvent. So I'm looking for on the graph, where does 50 grams of lead nitrate dissolve? So any temperature, so there's the 50. So I came from here over and then dropped it down, and that's 12 degrees Celsius. So any temperature above 12 degrees Celsius, I should be able to meet that dissolving amount. Next thing we're asked about is the temperature I would need to cool the solution to see 20 grams precipitate out. So notice what I did here. So if I'm adding 100 grams and I want to see 20 precipitate out, so the idea is that I want to be 20 over the limit, because when I'm 20 over the limit, then it would settle out to the bottom. And so then I figured, okay, well, if they gave me 100 to be 20 over the limit, I'd have to be down to a solubility of 80. And so I looked on the graph, and that is right here, right? So that's right at the 42 degrees Celsius. So I would need to cool down. So obviously the initial, to get 100 grams dissolved in the first place, would have to be above 42 degrees Celsius, cool it down below that, and, down to 42. And that is where we'll see the 20 extra grams of solute precipitating out. And then lastly, how much water at 20 degrees Celsius would be required to dissolve 300 grams. So this is where a lot of people had some issues. You got to read carefully. So 20 degrees Celsius, so this is the solubility limit at 20. So that's the first thing I would look at, is read the graph. What conditions am I talking about? So I could dissolve 57 in 100. This is asking me about 300 grams of lead-2 nitrate. So this is not the mass of solvent this time. This is the mass of solute. So that goes on the top in these proportions. And then on the bottom, well, it's obviously going to be a bigger number than 300. And it's going to be, well, solve it out, cross multiply, or however you like to do it. And that's 526 grams. So looking at problem set B for set 2, there are your answers. So again, this is for ammonium chloride this time. So again, notice all the same work I did out to figure things out. You can pause it if you need to. For set B3, there are what the numbers look like. Pause it if you need to. All right, so let's move on to set C. So these calculations for set C on all of the problem sets were calculations from the previous week. And so we were told, we know that, normally there's going to be some change in solution volume from solvent volume. But we're just told to pretend, at least for the sake of our calculations. So 57, that's the solubility we can read from the graph at 20 degrees Celsius in 100 grams of water. So that's how much would be in a saturated solution at that temperature in 100 grams of water. So that's where this comes from to start with. This is the molar mass of the solute, so this is lead-2 nitrate. If you look at the formula on the graph, it's PbNO3(2), and so again, we're multiplying everything on the inside by 2, and then we find moles, divide by that volume, which is supposed to be in liters, so instead of being 100 milliliters, we have 0.100 liters. And I did leave an extra digit on the moles here. If this mass from the graph is only 2 digits, that's why I rounded my molarity down, my final answer, down to 2 digits, 1.7 molar. So notice the capital M at the end, meaning that it is a solution concentration. Grams of lead nitrate, how much would I need to, so again, this is using the molarity equation. I'm given the volume, got to convert this to liters first, given the concentration, so the molarity times the volume gives me the moles, and so I didn't write them out separately so you can see it, but these liters should be canceled. When I multiply liters times moles, times molarity, I get moles, and then I'm multiplying that by the molar mass. Again, this is the molar mass of lead-2 nitrate. I already figured it out up here, so reuse it again. And that gives me 16.6 grams. Number 3, this is the dilution problem, so we need the dilution equation. So a lot of people used the wrong equation. So this is what we did in the lab. So my more concentrated solution, notice when I solve this, I need a lesser volume of that because the more concentrated, to get that same number, that target number of moles in the dilute solution, then I need a smaller volume. So I only need to measure out 125 milliliters of the 12 molar. And then I will have my new concentration solution out of that. Lastly, number 4, a lot of us didn't get to these, but stoichiometry. So just to review, the stoichiometry means we're talking about a reaction. We have an amount of one substance and we're asked about an amount of another. Got to read carefully and see what they're asking us for. So this is milliliters of lead-2 nitrate solution. So that's our given information. We are told that it's reacting with sodium chloride. It's excess, so we don't have to worry about how much of it we have. Calculate the mass of lead-2 chloride. So you got to pay attention. I'm looking for lead-2 chloride. That is this guy right here. And so we're going from amount of lead-2 nitrate to the amount of lead-2 chloride. So the steps for stoichiometry, I need to use the balanced equation to relate amount of lead nitrate to amount of lead chloride. Since the coefficients are in terms of moles, the first thing I want to do is find moles. And since I'm given a volume and molarity to find moles, I use the molarity equation. So I'm multiplying the volume times the molarity. That will give me moles. So I didn't write out the individual calculations in between, but that gives me moles of lead nitrate. So whatever this is the concentration of, that's moles of that. Next step is this mole to mole ratio. So these are the coefficients from the balanced equation. And it happens to be 1 to 1. So if you forgot this step, you could still end up getting the right answer, but that doesn't mean that you know what you're doing. So notice that this is where we change from the moles of lead-2 nitrate, which is what was given, to the moles of the thing we're asked about. So now after this step, we'll have the moles of lead-2 chloride. And then from there, lastly, if we're asked for a mass of lead-2 chloride, That looks very much like a lot of the other problems we've done. So I would want to multiply by molar mass, and this is the molar mass of lead 2 chloride. So it's PbCl2. So 1 Pb plus 2 Cls, and that comes out to this. So multiply all that together, I end up with 1.74 grams of lead 2 chloride. So let me scroll down to the other problem sets just so you can have a look at them. So it is the same exact setup. So you'll notice if you rewind the video back and look at the difference in the answers, the setup is exactly the same. It's just a matter of putting in the numbers from the particular problem, the correct molar mass for the thing that you're talking about, correct coefficients for the things that you're talking about, and then move on to the last set. So there you go. This I confused myself. The product we're looking for is mercury chloride, so this is the right number, 5.09. All right, so there you go.